All right, chemists. So today we're going to talk about, really get into what people classically think about when they think about chemistry. And we're going to be talking about atoms. Now, um, atoms are so small that we can't see them with our own eyes. Even the most powerful microscopes that we have in the world are just barely getting to the point where we can better visualize atoms. So what atoms are for us, they're models. They're a way for us to take what we know right now, the best evidence we have, and put it into an uh, understandable method, or a way that we can better understand the way matter works. So, really, what a model is a simplified representation of something more complex. So, uh, it helps us understand aspects of a real object or process. Helps us understand aspects of a real object or process. And we use modeling a lot in the scientific world to help us understand things that are really complicated. So, an example would be the solar system model that you see, where you have like the 8 planets around the sun. That's helping us understand something much more complex. It's not completely accurate, but it gives us a basic understanding. And we're going to see with atoms that was the case. That's the case too. So, atom is defined as the smallest particle of an element that retains the chemical property of that element. Chemical properties of that element. So basically, once you break down an atom into smaller pieces, it no longer has the same properties as that original atom. So if you take an atom of carbon and split the nucleus, you no longer have something that will behave like carbon anymore. All right, so more notes. And these are hopefully things that you guys have heard about before, but we'll just take these notes down to make sure we understand completely. Nucleus is the dense, positively charged structure found in the center of the atom. It is made of protons and neutrons. Okay. So you have these protons and neutrons in the nucleus. Essentially, all of the mass of the atom is contained in the nucleus. The electrons have a teeny, teeny, tiny bit of mass, but you can think of the masses of an electron similar to this analogy. If you're Bill Gates and you walk down the street and you pick up a nickel, does Bill Gates now have $1 billion in a nickel? Well, no, it doesn't really change his wealth that much. Whereas if I walk down the street and pick up a nickel, I'm like, that doubles the amount of money I have. But for somebody who's rich, adding a dollar or a nickel or whatever doesn't really change their wealth. So for electrons, adding electrons to an atom doesn't really change their mass because the neutrons and protons are so massive compared to them. So a proton is a particle with a positive charge found in the nucleus. An electron is a particle with a negative charge and that's found outside the nucleus. And the electrons are moving around so fast outside the nucleus. That's why we can't put our hand through a solid object, is because the electrons in our hands repel the electrons in the table or whatever solid substance. So they're moving around so fast, it's like trying to stick your hand through a fan blade. That's why we can't stick our hands through solid materials. A neutron is a particle with no charge found in the nucleus. All right. Okay, so for today, the question we studied was, how are the smallest bits of matter described? And we learned that all matter is made up of extremely small particles called atoms, too small to be seen even under a microscope. The atom is composed of even smaller particles called protons, neutrons, and electrons. Those are actually further broken down into things called quarks, but we're not going to be studying quarks. The protons and neutrons are in the nucleus. The electrons surround the nucleus. Protons have positive charge, and neutrons are neutral. That's how you remember. Neutrons, neutral, neutrons, neutral. From what we saw today, science is theoretical and dynamic, and that we're constantly being revised. Models are constantly being revised or replaced with new models as evidence is gathered. So this is one of the coolest parts of science, is that you're not entitled to your own facts. So we have evidence for something, and if we get new evidence that doesn't fit into a model, that model is wrong. So, for example, when Galileo created the heliocentric model of the universe, or of the solar system, previous to that, we thought the Earth was the center of the solar system. And from Galileo's evidence, we knew better, so we had to change what model we had. So atoms could be wrong. But to date, every shred of evidence we have follows the atomic model. Okay.